Welcome to my note series videos. So today we are going to be looking at heat, and under heat we are going to be looking at what is temperature. We are also going to be looking at different types of temperature scales, and then finally we are going to look at relations connecting the temperature scales. So what is temperature? So temperature of a substance is a number which expresses its degree of hotness on some chosen scale. So this tells us quite a number of things. So firstly, it tells us that we are looking at a substance or an object. And also it tells us that temperature is a number. So after it has told us that temperature is a number, now it tells us that it expresses its degree of hotness on some chosen scale. So it means that there are a number of scales possible for temperature. So what are those scales? Well, if you look here, we firstly have the Celsius scale, which we usually express in general with its unit as degrees Celsius. Then we also have the scale that Americans use, which is the Fahrenheit scale, which is expressed as degrees Fahrenheit. And then finally, we have the Kelvin scale, which is also known as the thermodynamic scale. So now let's firstly look at the Celsius scale. So if you look at the Celsius scale, what do we know? Well, we are aware that at 0 degrees we call this the melting point. So this is the melting point of water. And now this is very important to know. This is not just any melting point, but it is the melting point of water. So now that we have defined that, we know of another point which is 100 degrees Celsius, which is defined as the boiling point. The boiling point of water. So now we know 2 points on the Celsius scale, and what we can notice is that between 0 and 100 there is a difference of 100. So now it means between 0 and 100 there are 100 degrees or 100 Celsius degrees. So we can say there is 100 Celsius degrees. Now this is very important, especially when we are relating different scales. Now when we move to the Fahrenheit scale, I'll just write F as for Fahrenheit scale. So for the Fahrenheit scale, what we know is that the melting point is now expressed as 32 degrees Fahrenheit. This is the melting point of water. So you can already see the difference. For the Celsius scale, when it's 0, for the Fahrenheit scale, it is 32. Now, for the boiling point of water, it is 212 degrees Fahrenheit. So this would be the boiling point of water. So now we know the boiling point of water, the boiling point and the melting point. So now as we have seen these 2 points, we can notice that if we take a difference, we will get 180. So it means that for the Fahrenheit scale, there are 180 Fahrenheit degrees between the melting point and the boiling point of water. So now, moving to the final scale, which is the Kelvin scale. So what is happening in the Kelvin scale? So the Kelvin scale, what actually happened was they plotted a graph with temperature in degrees Celsius excuse me, and volume in meter cubed. So what they did when they plotted these two variables against each other, they got a straight line. So they did various experiments. We can say this was perhaps guess 1, this was guess 2, and this was guess 3. So if you look at these three straight lines, they represent the relationship between the volume and the temperature of the gas. So what happened was, when they extrapolate to a point where, I'm sorry about this graph not being to scale, but when they extrapolated, all these graphs came to a point which is minus 273.15 degrees Celsius. Now, when they did these experiments, they noticed that when the volume is 0, this is the temperature. Now we know that the volume of any gas cannot be 0, because for a particle to exist, it must occupy some volume. As we define matter, we say it must have mass and it must occupy a certain volume. So now, when they realized that this is the point they get, then Lord Kelvin, which this temperature scale is named after, then said this point is known as the absolute zero, which is the lowest possible temperature on Earth. Now, with that being said, we have looked at the three scales. We have looked at the Celsius scale, we have looked at the Fahrenheit scale, we have looked at the Kelvin scale, and now we are going to look at the relations between these what you call scales, or temperature scales more precisely. So when we look at these relations between these temperature scales, we find a relation like this: C minus 0 over 100 is equal to F minus 32 over 180 is equal to K minus 273 over 100. So now, what is happening here? So the relations between these temperature scales is a means or an aid of helping us to convert one unit from another. So if you get a temperature expressed in Celsius degrees, for instance, this relation can help you to convert it to Fahrenheit. It can help you to convert it to Kelvins. And as you are going to learn as you go on, that for all your calculations relating to thermodynamics, you have to have your temperatures in kelvins. So getting a temperatures in degrees Celsius or Fahrenheit, you can then use this relation to actually calculate the temperature in a different scale. So let me make an example. For instance, if you are given that the temperature is 32 degrees Celsius, then you would substitute your 32 here. If you wanted to convert it to Fahrenheit, then you will hide this. So you can see that you only have F as an unknown, because you already have 32 as the temperature for in degrees Celsius rather. And also, if you wanted to convert to kelvins, you can hide the middle parts, and if you hide it, you only have kelvins as the unknown. Now, if you look at these relations, remember when we spoke of divisions. So we said for a Celsius scale you have 100 divisions. We said for a Fahrenheit scale we have 180 divisions, Fahrenheit divisions. And also for a Kelvin scale we have 100 divisions. So you can see 0 was the melting point of water, 32 was the melting point of water in Fahrenheit, and 273 is the melting point of water in the Kelvin scale. So now, with that being said, we have covered what we aimed at covering, and you can now use this information and try to apply it to your calculations that might be troubling you. Until next time.